The dotted lines represent the undeformed positions, and the Z plane is this one. Points where the stress interacting are these. So it is sigma x and sigma x, sigma y and sigma y. Now the points belonging to the positive phase are this point and this point, and at these points the positive directions are this and this, and center. This force creates a cup. This shear stress needs to be counterbalanced by another shear stress equal and opposite here. In the same way, this shear stress by this shear stress. These two shear stresses tend to deform the body in this direction, and these two shear stresses deform the body in this direction. Since the body is under equilibrium, these two couples must be equal. Or that means that the moment created about this point by this, and the moment created by this force at this point, both are equal and opposite. So how does this body deform? This is the axis of symmetry, okay, as with respect to the forces acting. Now this is the resultant of these two. Now it expands here and here and contracts here. So the deformed position is this one, okay. So now we have the deformed state and as well as the normal stress components written down, and we have understood the concept of shear stress in this case. So let us now go into how do we write the values of shear stress in terms of tau xy or tau yz. Okay. Now shear stress is denoted by tau. It's a symbol for shear stress. Now this is a shear stress, this is a shear stress. They both are acting in a plane called the x plane, and this x plane forms the shear plane for these two shear stresses. So we write this down as tau acts in the shear plane x and along the direction z, and this one will be tau x y. So in this way we will write down here. Consider the x plane. In the x plane, I will write down the undeformed position once. and this body looks like this in 3D. And for this, okay. Now for this, okay, X, Z, Y. ಸ್ವಲ್ಪ ಮಾಡ್ಕೊಡಮ್ಮ. Y, X, and Z, Z, X, and Y. Sigma Y. I don't have to explain much because you already know what is coming here. Sigma X, Sigma X. Positive direction along this point is this one. Positive direction along this point is this one. And as we explained here, we need counterbalance the deformation, so we need shear stress in these directions as well. Okay, now writing this value, it is tau x plane, and it's acting along y axis, and this is tau z, and this is y plane because this plane is perpendicular to y axis, so tau y, and then acting along tau y, and it is acting along the x axis. So similarly, this must be equal to this because they need to counterbalance each other, and this was tau yx. This must be equal to this tau xy, and if we consider this one, it is again x plane and tau x, but this one is acting along the z axis, tau xz, and tau, and this is the tau this is the x plane, tau x and z, and we have this should be tau x z also. Okay, and this is tau z x, tau z, and this is the x midplane, and this normal force is here is along the z direction, and it is normal to the z plane, so this is in the shear plane of the z, so this will be tau z y. Similarly, this should be tau z y, Now coming for these two. Now this shear stress is acting at this point. The normal stress here at this sigma y. Sigma y is normal to the y plane. Tau y z, and this should be tau y z. So writing down the everything here. So tau z x, this should be tau z y, and negative direction is this, and this tau z y and tau z x. Okay, now this is tau y x, tau y z, negative direction for this, tau y z, tau y x, this one, tau x z and tau x y. Seems we have done. Yes, this is how we write the stress components. Have you understood? Thank you.